Lesson 3.4 is on proofs with perpendicular lines. There are 3 theorems that I asked you a few days ago to add to your notes. They are the linear pair perpendicular theorem, which says if 2 lines intersect to form a linear pair of congruent angles, then those lines are perpendicular. And it helps if you have the drawings, so it's a good idea to go to page 150 and put those drawings in your notes as well. The second one was the perpendicular transversal theorem. And that says that in a plane, if a transversal is perpendicular to one of 2 parallel lines, then it has to be perpendicular to the other one as well. The transversal is perpendicular to one of 2 parallel lines. It's perpendicular to the second one as well. The third one is the lines perpendicular to a transversal theorem. And it says in a plane, if 2 lines are perpendicular to the same line, then those lines have to be parallel to each other, which kind of makes logical sense. So, the other most important thing that you need to know from this section is that when we're looking for the distance from a point to a line, we have to make sure that we're looking at the perpendicular segment from that point to that line. Okay? The perpendicular segment is crucial that you are looking at that one and not the other ones. So let me show you an example or why this is the case. If I go to my website, this chapter is parallel and perpendicular lines. And if we scroll down, we've done a lot so far. This is the GeoGebra applet that I want to show you. And we can hide some of this stuff. All right, so we have a point P here. And we have a line. Okay? When we want to know the distance from this point to this line, we're concerned about the shortest distance possible. So when I ask you, how far do you live from Giles Road? Or how far is it to Giles Road? I'm not concerned about how far it is from 96th to Giles Road, or maybe it's from 72nd to Giles Road. I'm only concerned about your most direct distance. Does that make sense? Okay? So when we look at this guy, here's my point P. If I want to know the distance to this line, I'm going to draw a perpendicular to that line and find out how far is this. Make sense? I don't care how far it is from here to this line or in this direction to the line. I only am concerned about the perpendicular. So this applet gives us a nice way to show it. We show the perpendicular. I didn't do a very good job of drawing that perpendicular, did I? But as we show that perpendicular, as I move that point around, let me eliminate my lines now. As I move this point around, notice that the perpendicular moves as well. And when I show the distance here, watch what happens. It's 4.99 right now. I'm at 1.8 there, 1.8 units, and so on. So I can bring this point wherever I want to, and whenever I'm looking for that distance, I'm looking for the perpendicular segment that includes that point. So far, so good? Okay. So, minimize this and back to where we're going. When you look at your first example, this is number 1 in the box that we're working together. Which points are we concerned with when we're finding the distance from that point to that line? Okay, we've got C, D, A, and B. We want to know the distance between point A and this line. So if I want the perpendicular distance, which point should I work with? C, D, or B? D. Because why? It has the right angle. Okay, it's got our right angle here. This is the point I'm concerned with. So I'm looking for the distance between A, which was -1, 8, and D, which is -4, 2. The rest of it's extra. We don't need to worry about it. Okay, how do I find the distance between 2 points? Distance formula. And what I want you to do with this every time you write one of these down is to write the distance formula. It will help you memorize it. Okay, what is the distance formula? Plus, someone said? Perfect. The only other thing I need is a square root. And don't forget to keep that square root. Don't get lazy and drop it and not write it, because a lot of you missed a point on that midterm because you didn't keep the square root going. You ended up with 32 as your answer, but it was the square root of 32. Yes, sir. Okay. Yes, sir. I'm sorry. Oh, you need a copy? My fault. Yes, sir. Absolutely. Okay. There's nothing wrong with the way this is written. You'll get the same answer, but we typically see the distance formula as the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Crucial pieces, we're subtracting our x's from our x's, and we're adding in between, and we have to follow our order of operations, our PEMDAS, and make sure that we square things properly. Okay? So either one works. This is the traditional way. The second one is the traditional way of writing it. Okay? You decide which one's going to be x1 and x2 and y1 and y2, but make sure that you are subtracting x's from x's and y's from y's. That was another mistake that you made on your midterm, some of you. So if it's helpful to rewrite this with an x sub 1, y sub 1, x sub 2, y sub 2 over the top, feel free to do that. That helps you with the formula. Then make sure you write the formula each time. It will help you remember it. Repetition helps. So let's plug them in. My x sub 2, my second x is a -4. I'm subtracting a -1, and I'm going to square that. And then I need the y sub 2 minus the y sub 1. My second y is 2. My first y is 8. And I'm squaring that. And don't forget to carry your radical down. Okay, if you want to do a Henry Ford assembly line and at the end put the radical in, great, but you might forget and you might get the wrong answer. Okay, what is -4 minus a -1? Minus a minus becomes plus a positive, so -4 plus 1, -3. We're going to square that. What is 2 minus 8? -6. We're going to square that. So -3 squared is 9. -6 squared is, and 9 plus 36 is 45. We'll have the square root of 45. James, you're writing this down, right? Okay. James, I said, I'm sorry. Okay. So square root of 45. Is that a perfect square? No. Is there a perfect square in it? Yes. What is it? We added them up, and we've got 9 plus 36 is 45. 45 is odd, so it's divisible by 5. 5 times 9, right? So this is really the square root of 5 times the square root of 9. Is 9 a perfect square? 3. So the 3 can come out. Is 5 a perfect square? No. So the 5 stays in. This is the best answer you can give me. And it's good practice for Algebra 2. because we're going to ask you to always simplify radicals like that. So I would accept square root of 45 as your answer. I would recommend simplifying to 3 square roots of 5. It's good practice for next year. So there's less to learn. Okay? Everybody good with that one? So ignore the extra lines, ignore the extra points. You're only concerned about the points that are connected by that perpendicular segment to that line. Okay? You're going to do 2 and 3 yourselves. Okay? I can't for them. I'll go back to it. We got to keep going so we get finished before lunch. You're going to do 2 and so you have example 1. Okay? You've got it all written down, so you've got an example just like it. 2 and 3 are on your own, and we're going to work on number 4 next. Yes, sir. The distance, these are both the same. You can use either formula. Jarrett suggested this because he's used to doing slope. Distance is similar to slope. We start with y2 minus y1 and x2 minus x1. But either one works. Okay? You choose which one you want to use. All right, here we go with the next one. Determine which lines, if any, must be parallel in the diagram and explain your reasoning. Okay, this is number 4 on your sheet. So which lines do you think are parallel? A and B, very good. Why is it A and B? So we have to be able to explain why. They're completely straight, not touching, but what marks tell us that it's going to be their right angles. Notice these right angles. Those are 90-degree angles, right? We could prove it by using corresponding angle theorem, right? But don't we have a theorem that we wrote down for this set from page 150 that helps us with this? A is parallel to B because you could use corresponding, but there's one specific to it that's going to save us a lot more time. It's called the lines perpendicular to a transversal theorem. Everybody good with that? Okay. All right. So that's example 4. You've got 3 like it, 5, 6, and 7. So now we have one more to go, number 8. Number 8 is our proof. We want to prove that perpendicular transversal theorem so that we can use it. And we're going to use the alternate interior angles theorem to do it. Okay? So we're going to start with the given that H is parallel to K and J is perpendicular to H. They told us that in the drawing. Here's our parallel, here are our parallel lines, and here's our perpendicular mark. So that's our given. Okay. So what's our next step going to be? They gave us a hint. They want us to use alternate interior angles. Is 2 an alternate interior angle to anything? 2 and 7 are alternate exterior angles. So we're going to have to do something to get some interior angles here. Okay. So 3, good. I like where you're going. Angle 2, let's write this down. The measure of angle 2 is 90 degrees. Everybody okay with that? Why is that? Yep, definition of a right angle or of perpendicular. Okay. And 3 is an interior angle. They want us to use alternate interior angle theorem, right? So how do we get angle 2 equal to angle 3? Vertical angle theorem, good. Okay. So does that mean that 3 is equal to 90 degrees? Okay. That's by substitution, right? So how about 5? Nope, not 5. How about 6? What would 6's measure be? Good. Why? Measure of angle 6, 90, because how is it related to 3? Alternate interior angles. We have 2 parallel lines cut by a transversal. Alternate interior angles are congruent. Abbreviate. Don't write too much. Write your radicals. You don't have to write all of the alternate interior angle stuff, though. Okay? So that means that if 6 equals 90, what kind of angles do we have here? Or what kind of lines do we have here? Perpendicular. So J has to be perpendicular to K by definition of perpendicular. Perpendicular lines form right angles. So we've proven that perpendicular transversal theorem. We could have more steps here if we wanted to say, since they're congruent, they have equal measures by definition of congruence, but it's not necessary. Okay. All right. So your job is to finish this. You have 7 more to go. We're going to go to lunch here in just a moment, but I want to give you your assignment for homework, which is a foldable. Okay. What about, I'm sorry? We just did 8 together. I can go back. I can go back and show you those. You can, you just give me a second. 2, 3, 4, 5. All right, this is going to be your all about slope foldable. And it's very, very, very crucial that you have this one done tomorrow, because we're going to be needing the information on it. It is on the website, you bet. And for those of you who don't have easy access to the web or have a sibling who's always bothering you or what have you, I have a couple copies that you can use to write things down if you don't have access. I want you to flip to the back side first. Okay? He waved his hand first. I'll give you a copy. Back side. Okay? On the back side, in the top left corner, I want you to write types of slope. Okay? Top left corner of the back side, the blank side, write types of slope. That's all you're writing in that square is types of slope. Okay? Same thing, back side, on the blank side, on the upper right, I want you to write slope. Okay? Middle right box, on the back side, you're going to write parallel lines, or you can draw the symbol for parallel lines. Okay? In the middle, on the right-hand side. Sorry, left, my fault. On the board, follow the board. Okay? Left side, parallel lines. Middle right box, slope y-intercept, or slope y-int, if you want to abbreviate. Lower left is going to say perpendicular lines, so you can use that perpendicular symbol. The upside down T. And bottom right is going to say point slope. Designed it so you don't have to do any cutting unless you want to do the flaps. So I have scissors and you can make cuts in just a bit. And then I'll give you the, I'll put the bigger piece up there so that you can see that as well. Now, I want to introduce you to one guy real quick here. Oh, never mind. Lunchtime. Let me introduce you to Mr. Slope real quick, and then I'm turning you over to take your notes and to finish your sheet. Okay? Mr. Slope, kind of a sad-looking guy, but notice that his left eyebrow goes up and to the right. That's a positive slope. Okay? His right eyebrow goes down to the right. That's the negative slope. Okay? What happens when you have a vertical line? What kind of slope is that? Undefined. There's his mustache, or the bottom of his nose. Okay? And what happens when you have a horizontal line? What kind of slope do you get? 0. Those are his dimples. Okay? So Mr. Slope can help you remember when slope is positive, negative, undefined, and 0.